So we're back again. The last set of operators that we want to work with are assignment operators. So we create a new project that we call assignment operators, where we want to be able to see how the assignment operators work. So for assignment operators, we can change how we have been doing things so far, and we can work with assignment operators in the following manner. So we would want to have new variables whereby we say int ans for answer, num1, num2, right? So these then become our values. So we want to actually set values for num1 and num2, and ans will be our answer wherever we have issues that we need to solve. So we'll start by saying num1 is equal to 10, num2 is equal to 24, like that. So what this then means now is we want to give each of our operators its own value, if I can put it that way. So we then want to be able to say, let's say, for example, we say ans is equal to num1 plus num2, like that. This then gives us an answer that adds the two values. Okay, so if we add the two values, we have literally used the equal sign in this particular example to give an answer to num1 and num2. So let's say we put a print f, we go and we then display answer. So answer is %d, we put a new line, put a comma, and then we'll put our answer. So if we run it, we'll then be able to get our answer is 34, and 34 we get it from 10 plus 24. That's what we've got. Okay, so to get to the next stage, we then want to say after this particular point, answer now has a value. So we say answer is equal to 0, so that we start again, and then we want to go to the next assignment operator, which is plus or equal to. So we then want to say our answer is supposed to be plus or equal to a specific value. So we then say answer is plus or equal to num2, like that. So that way we can then be able to display the value for answer, and it then gives us plus that value. So we're saying answer then gives us 24, right? Because in this particular case, we've got an issue now, which is a positioning of our plus. So because our plus is before the equal sign, it means we only get our answer after this has been done. So if we are to then get this, we need to then get into postfix and prefix, which we'll eventually get to, but as of now we are just persisting with our assignment operators. We can also do the same with the next value, which is minus or equals to. So I can just copy this as it is, and then I just change the plus and put a minus or equal to, but we are still going to get the same result okay, we are getting a slightly different result. We now have a minus, so it changes the value of our 24 by having the minus before the equal sign, although it's supposed to actually change and give us another value. Maybe I'm explaining it wrong, but as we go along, I'll try and give you answers if you've got questions based on what we would have done. So the next element is also our multiply or equal to, right? Multiply or equal to. So let's actually state that this is assignment equal. This then becomes assignment add. This then becomes assignment subtract. And then the next one becomes assignment multiply. So if we just close this and run the new extra one, which is the minus and the multiply, would actually then find that our assignment for the multiply gives us 0, because we've multiplied 0 plus by 24. If we actually want to see a different value, let's actually just change this, and we won't want to put we can then say that is now equal to num1, and then num1 gives us a new value, which then gives us 240. Okay, so we can also do the same for the divide, where our divide is an assignment by divide. Assignment divide. So remember to change that portion, and also remember, okay, it will still give us an error like we had the other time. If I run it, it gives us 0 because we are dividing by 0. But if you want to see something different, we can also do what we did in the other part, which is num1, and then if we run it, we'll still get 0 because now we're dividing 10 and 24, which won't give us a result because num1 is less than num2. So we can safely say that that works. We've got another few sets of our assignment operators. We'll still work with them until we get what we would want to get. So in this particular case, I want to use the modulus that we had for our arithmetic, but I want to use it in a slightly different manner. I would want us to say our answer, in this particular case, we want it to be equal to 0, but we then want to be able to say our answer is equal to our num2 percentage num1, like that. The reason why we're doing this is we want to say if we divide these two, we are supposed to get an answer. So that answer then becomes what we are looking for. So if I just copy this printf and put it there and run it, I should be able to get 4, because that is the remainder that remains when we divide 24 and 10, we get a remainder of 10. So that is our assignment operator. Or we could actually put it we are literally assigning the modulus, although we could try and do it this way. We could try and say our answer percentage equal to num2, which should give us pretty much a different modulus, but can give us an answer. Can give us an answer that we are looking for. Let's just see what that gives us. It gives us something, but yes, it still gives us 4. Let me just check one thing. Let's just reassign answer to be equal to 0 and confirm if it gives us the same answer. No, it doesn't give us the same answer. It was actually giving us an answer before. So we're then saying if we put it this way, we'll still get the modulus, but it's the modulus of 0 because of what we would have done. If we want to see something similar to what we've done there, maybe we can say num1, and then this becomes num1 like that. That should give us something slightly different. Okay, so it didn't give us the answer that we were looking for simply because of the way we had put our num1 and our answer. So modulus pretty much gives us the remainder of anything that would have been divided. So in this particular case, we've divided 10 by 10. We still get 10 because there was no other number that we have actually divided. But in this particular instance, we have divided something, so we then get a 4. So maybe these two can work hand in hand, and you can see how our modulus works. If you've got any questions, feel free to ask me in the comments section, because I do expect questions, because I may be moving a bit fast, or there may be certain aspects that you may not have understood in how I've been explaining. So we move on to the next operator that we can work with. We can have an assignment operator, which is also a bitwise operator, whereby we simply say the following. We want to be able to get the answer, but this answer, we want it to be the left shift of 2 bytes for our answer, right? So in this particular case, let's actually change our answer to 34, and then we want the left shift of that answer. And then this left shift of that answer, we then want to be able to say print f, and this print f, we are then saying we want to be able to get answer is percentage d. We'll put a new line, and then we get our answer like that. So remember, if we want to close this, you just press any key. Sorry, I did not mention that, but okay, now we are getting an issue with this particular bit. Oh, I put one extra equal sign. My mistake. Yes. So this then means we've added 2 bits to the answer, which is 34, and that gives us 130 or 136, and we are done. Let's actually just name what each of these other elements do. This is assignment modulus. This is assignment left shift, and then we also do the same for ANNS equals 34, and then we then copy answer right shift equals to 2, and then this is assignment right shift. So we have a printf answer is %d with a new line, and we then get our answer. So if I run it, we then now get, for our 34, it now goes back down to 8. So that's our right shift assignment operator. There's 3 more left, and then we'll be done with our assignment operators. We want to be able to put a bitwise AND, a bitwise OR, and a bitwise OR has 2 variations: bitwise OR exclusive, bitwise OR inclusive. So the first one we work with is a bitwise AND operator. So we then have our answer is equal to 34. If our answer is equal to 34, we then want to be able to say our answer and equal to 7, like that, which is assignment and rather bitwise AND. And then I can simply copy this instead of typing as I'm doing. Control copy, Control V, where we get the answer, and then the answer is what we would have done. So let's just run it and see what our answer is. We then find, after having our answer being 34 and we use the bitwise 7, our answer becomes 2. We now need to move on to the next one, which is the exclusive OR. Right? The exclusive OR is as follows. We simply put the angle is equal to, and then we put the value that we want to work with. So let's say in this particular case I want to work with 1. So this is our assignment OR, which is inclusive. So we get our answer. Let's see what that gives us. That gives us 35. So it just adds 1 to our particular value. We can do the same for the last one, which is our answer is equal to 34. And our 34, we want an inclusive OR. and our inclusive OR will then put 8. And then let's see what our answer is. Our answer remains as 34. Oh, sorry, I've got my mistake there. I was supposed to put the right I'd actually made an error on line 41. I'd put an exclamation mark instead of the straight line. So that then gives us the values that we get with each and every one of these elements in our assignment operators. So this is how we use our assignment operators, and the results that we